So in the last class, we started with the periodic table, and we have studied about different groups. Specifically, there are 3 groups whose details we have studied. That is group 1, which is alkali metals. Group 2 has a similar properties of group as compared to, similar properties as of group 1. Then we did group 17, which is halogens, and group 18, which is noble gas. So now let us understand about the trends across the group and periods, and what are different trends. Okay. So what are different trends? So let us understand. The trends across the period and group. Trends across the period. So across the period means it is left to right and down the group, which is top to bottom. Okay, across the period, left to right, down the group, top to bottom. The first trend is atomic size. Atomic size is nothing but it is distance traveled from nucleus. So distance from nucleus to outermost shell. To outermost shell. Okay, so distance from nucleus to outermost shell. Now over here, if we talk about across the group, across the period, from left to right and down the group. So let's take an example of period 2. Across the period, let's take sodium, magnesium, and aluminium. And down the group, we'll take an example of lithium, sodium, and potassium. Whenever you have a doubt in the trend, always the best way is to write the electronic configuration. The sodium, the electronic configuration is going to be 2,8,1. For magnesium, it is 2,8,2, and for aluminium, it is going to be 2,8,3. Now, what do you think will be the atomic size? Will it decrease or will it increase across the period? What will happen to atomic size? Yes, Arpita, can you tell me?
Can you repeat the question?
My question is, what will be the effect of atomic size? Will it increase or will it decrease across the period, left to right?
It will increase.
Okay, it will increase. And down the group?
Wait. If it's across the period, I don't think it can increase. It will just stay the same across the period.
Okay.
And then down the group, it will increase because
Okay,
if it's across, it needs to get filled before there's another shell added on to it.
yeah. Okay, let us check. Let us check. So Salma, even your answer, which is increase. So let us check. Now, when we talk about sodium, now sodium is the center element. 1, 2, and 3 shells. So outer shell, 1 electron. Magnesium, 1, 2, 3 shells. Magnesium, 2 electrons. Aluminium, 1, 2, and 3 shells. 3 electrons. And in lithium, we have already learned lithium, sodium, and potassium. Since down the group, it is very clear. Down the group, it is very clear that number of shells increases. Number of shells increases So definitely atomic size will also increase, because distance from the nucleus to the outermost shell will keep on increasing. Lithium, the outermost electron is in the second shell. For sodium, the outermost electron is on the third shell. And for potassium, the outermost electron is on the fourth shell. So distance from the nucleus to the outermost electron keeps on increasing. But what about across the period? Will it decrease, increase, or remain same? The answer is across the period, across the period, across the period, atomic size across the period, atomic size decreases. It does not remain same, but it decreases. Now, question, why it will decrease? We understand that it will not increase because number of shells remain same. The distance is same. Sodium, the last electron is on the third shell. Magnesium also, it is last electron on third shell. And for aluminum also, it is at the third shell, which means the distance is same. All the electrons across the period, if they are from the same period, the distance of the last electron is at the same distance. So why there is a decrease in atomic size? The reason is because due to nuclear charge attraction. Due to nuclear charge attraction. Now, what is this? Can I say that sodium will have 11 protons inside the nucleus because its atomic number is 11? Magnesium will have 12 protons and aluminum will have 13 protons. So can I say that as you are moving from left to right, number of protons is increasing? Can we say that? Yes or no? As you are moving from left to right,
Yes, yes, yes.
can we say that number of protons increases? So if the nucleus is becoming more and more and more and more powerful, so it has the ability to attract electrons towards itself. So over here, let's understand nucleus is acting like a magnet. Now, nucleus is a positive charge, electrons are negative charge, so there will be definitely some kind of an attraction. Now, what if the nucleus is becoming more and more and more powerful? For sodium, there was only 11 protons. For magnesium, now the proton has increased to one more, which means 12 protons. Then aluminum, 13 protons. Silicon, 14. And it goes on, which means the center part is becoming more and more powerful. So more and more powerful means it has the ability to attract more electrons towards itself. So if more powerful, more attraction. So more attraction, because of that, the size of the atom decreases slightly as you go from left to right. So due to nuclear charge attraction, so as nuclear charge increases, as nuclear charge increases, there is nuclear attraction between nucleus and outermost electron. And that is the reason across the period nuclear charge, atomic size decreases. Down the group, yes, it is very simple. It is clear, which is increases. Is this very clear? Yes or no?
Yes, yes.
Please copy down this.
So is it like the across the period, since the nucleus has like more attraction, it like pulls like the shells kind of closer together?
Yes, yes, yes. Because there is a more proton, more more positive charge. So it's like you can imagine nucleus as a magnet. So more powerful magnet, it will try to attract the magnetic things towards itself because the distance is same.
So there's like less like size because it's more compact.
Yes, yes, yes. The next trend, second one, trend across the period and down the group. So now trend across the period, second one, metallic character. So if you are going from left to right in the periodic table, what happens to metallic character? Will it decreases or increases? If you check your periodic table, where are more metals and where are non-metals?
It decreases.
It decreases, yes, because metals are on the left hand side and non-metals are on the right hand side. So as you go from left to right, the metallic character keeps on decreasing. But what about down the group? So down the group, lithium, let's say sodium, potassium, 2, 1, 2, 8, 1, and 2, 8, 8, 1. Belonging to the same group, okay, down the group if you are going. Now, all the three have one electron in the outermost shell, but it is the potassium whose electron will be lost easily. Which means, can I say potassium is the most metallic? So as you go down the group, metallic character increases. Yes, metallic character increases because the ease to lose electron increases because of the atomic size. And let's go to the last trend, third one, non-metallic character. Non-metallic character, also called as electronegativity. Also called as electronegativity. Now, electronegativity is nothing but it is a tendency for an element or for an atom to gain electrons. Okay, so basically it is about the non-metallic character. So that's why I gave you a simple, you can say synonym for electronegativity. So it is going to be opposite of metallic character. Left to right, if
Yes,
metallic character decreases, then non-metallic character will increase.
and then down the group, metallic
Down the
character
group
decreases.
will decrease. Yes.
Yeah.
Okay. So once you understand metallic character, electronegativity is just the opposite. So you do not have to actually by heart. So just copy down this and we are left with one last part of periodic table, which will be done in the next slide. So please copy this. Okay. This is a part of acids, bases and salts actually, which is type of oxides. But yes, when we do some questions on periodic table, sometimes they do ask questions on type of oxides as well. So type of oxides, when we talking about with respect to the period. So as you go from left to right, okay, as you go from left to right, let's say period 2. Period 2, we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Sodium, magnesium, and aluminium, all three are metals. Silicon is a metalloid. Phosphorus, sulfur, chlorine are they are non-metals, and argon is noble gas. So you get all the 4 varieties in the group in period 2. So now if all of these are reacting with oxygen, okay, argon, there will be no reaction because it is inert. So what happens to this? So when you have sodium oxide and magnesium oxide, okay, Na2O and MgO and Al2O3, all these are metal oxides, and these metal oxides act as basic. So metal oxides in nature, they are basic. Okay, they are basic in nature. Then from SiO2, P2O5, SO2, and ClO2, all these are non-metal oxides, which are acidic. They are acidic in nature. And a very important note, Al2O3 also behaves like a non-metal oxide. So there is Al2O3, which is acting as a basic oxide as well. Sorry, which act as basic oxide as well, and acidic oxide as well. And they are called as amphoteric oxides. Amphoteric oxides. So the oxides which can behave both as base as well as acid are called as amphoteric oxide, and we have such example as Al2. So this is the part of acids, bases, and salts. So when you will be studying acids, bases, and salts, at that time you will learn about this oxide. So please just copy down this, and this is the last concept of periodic table, and then we'll solve the questions. The periodic table lists all the known elements. Elements are arranged in order of dash number. So how the elements are arranged in periodic table, based on what? We see the periodic table. So H is 1, then helium is 2, then we have lithium 3, beryllium 4, boron 5, carbon 6.
Miss, is it proton number? Because because the number of protons is atomic number and it goes up in atomic number.
Correct. That's correct. Very good, Aman. So it is not nucleon number. Nucleon number will be protons plus neutrons. So it is not based on atomic mass, but it is based on atomic number. So atomic number is same as proton number. So answer cannot be A and B. Now the melting point of group 1. What happens to the melting point of group 1? Increases or decreases down the group? Check your notes. Melting point of group 1.
Decrease.
Yes, it decreases, and melting point of group 7 increases down the group. Yes, so answer is C. Okay, next one. Which information about an element can be used to predict its chemical properties? Boiling point, density, melting point, or position in the periodic table? Yes, Arpit.
Can you explain again why the melting point decreases in group 1?
Yes, because lithium, okay, if we talk about group 1. Now group 1, we have lithium, sodium, and potassium. They are already soft metals. Okay, now soft metals, and they are highly reactive as you go down the group. So basically reactivity increases. So if reactivity will increase, it has a tendency to lose electrons quickly. So the bonds will break very quickly. If reactivity increases, the bonds are very weak down the group. So if bonds are weak, can I say it will melt easily? Because at the end, what is melting point? Liquid to solid to liquid, right? Yes, Arpita.
So the
Melting
liquid,
point is solid converting to liquid, right? Now
yes,
why let's say if I have a metal, let's say a piece of copper versus if I have plastic, why piece of copper will take a very high temperature to melt? Like if you take a piece of copper, you put it in front of a burner, and a piece of plastic, put it in front of burner, who will melt?
plastic.
Why it will melt? Because the bonds between the plastic are not that strong, so they will break, and then it will convert into that soft thing or melted form, but not copper. If you want to convert copper, to, let's say, liquid copper, then it takes a very high temperature. Okay. But if we talk about, let's say, group 17, now group 17, we have fluorine, chlorine, bromine, and iodine. Now fluorine, chlorine are gas, bromine is liquid, and iodine is solid. So as you go down the group, the reactivity will increase. So gas, liquid, and solid, who will have more melting point? Yes, Arpita, who will have more melting point? Gas, solid, or liquid?
Uh, the solid.
So can I say that as you go down the group, melting point will increase for group 17?
Yes,
So answer is C. Got it?
yes.
Okay. Okay, second one. Which information about an element can be used to predict its chemical properties? What do you think? Chemical properties means there is transfer of protons, electrons.
D.
Yes. Answer is D, because boiling point, density, and melting point are physical properties. Okay, physical properties. Next one. Which statement about periodic table is correct? So I'm giving you 1 minute. Everybody, please try to write the answers in the chat box. Which statement about periodic table is correct? Elements in the same period have same number of outer electrons, same period. So starting with, let's say we are talking about period 2. Lithium, beryllium, boron, carbon, and so on. Lithium is 2,1, beryllium 2,2, 2,3, 2,4. Do they have same number of electrons in the outer shell? Is it so, Salma? Are outer electrons same? No. It is actually same number of shells is same, but not the outer electrons. The outer electrons keeps on increasing. So A is an incorrect statement. The elements on the left are usually gases. No, it is actually on the right hand side, and that too group right hand side they are gases. Oxygen, nitrogen, helium, neon, argon, all are gas. So right hand side. The most metal elements are on the left. If you look at the periodic table, check your periodic table. Look at this. 1 second. Where are more metals? If you look, all these still here, all these are metals. So all the metals are on the left hand side of the periodic table. So C is the correct statement. Still, we will check the D1. The relative atomic mass of elements increases from right to left. The relative atomic mass of elements increases from right to left. They are talking like this, right to left. Is it decreasing or increasing? They are not talking of left to right. Check your periodic table. If you are going from neon to fluorine to oxygen to boron, is your atomic size increases? Aman? Yes, Aman, can you answer this? Does atomic size, atomic mass increases from right to left or left to right?
Miss, right to left?
Right to left increase hoga. If you are going to reverse, neon, fluorine, oxygen. So if you are going neon to fluorine to oxygen, neon atomic mass is 10. Sorry, it is 20. Okay. Fluorine atomic mass is 19. Oxygen atomic mass is 16. If you are going from right to left, reverse order, is your atomic mass increasing?
No, miss. The atomic mass is decreasing.
Because left to right increase hoga na, you have to always read your periodic table like this, not reverse order. So you misread the option. You thought that it is left to right, but actually it is right to left. Answer is C. Okay, last one. So again, giving you 1 minute. If it is in group 1, metal or non-metal? Group 1, it is going to be a metal. Metals are solid. So it is not a gas. It is not a non-metal. So A and D, A and C are ruled out. It is hard metal that is not very reactive with water. The peculiarity of group 1, the main characteristic of group 1 is that they are soft metals and highly reactive with water, with air and water. That's why they are stored under kerosene. Highly reactive with air and water. Answer is D. Okay. So let us go to the structured questions. Okay, let us solve some structured questions. Okay. There will be some questions of bonding as well, but that bonding is our next topic, which we are going to do it in the next week. Okay, so let us do question number A1. Okay, 1. Now, nitrogen reacts with lithium to form ionic compound lithium nitride. Write the equation for reaction between lithium and nitrogen. So it is going to be Li plus N2 because nitrogen is diatomic. Already the compound of lithium nitride is given to us, which is Li3N. Balancing the equation, there are 2 nitrogen, 1 nitrogen. So 2 nitrogens over here and 6 Li. So it is 6 Li plus N2 gives 2 Li3N. This is for bonding, so that we will be doing in the next topic. This is also for bonding. Okay, let's come to question number B2. Question number B2. So what is the answer for question number B2? Lithium nitride has a high melting point and nitrogen. Okay, this is also for bonding. So right now you will not know. Sorry, this is also for bonding. Okay, let's do this question. Question number 2A. Number of valency electrons. Yes, what will be the number? Sodium atomic number is 11, this is 12, this is 13, this is 14, 15, 16 and 17. So these are atomic number. Valency electrons, yeah, or valence electrons actually, to be precise, it has to be valence electrons. So for sodium, if we write electronic configuration 2, 8, 1, this is 2, 8, 2, this becomes 2, 8, 3, 2, 8, 4, 2, 8, 5, 2, 8, 6, and 2, 8, 7. So valence electron will be 1, 2, 3, 4, 5, 6, and 7. And if we go for the valency, sodium will have 1 valency, magnesium 2, aluminum 3, silicon 4, phosphorus 3, 2, and 1. No need to write plus minus. Okay, remember, no need to write plus minus. So over here, metals. So over here, if the valence electrons are 1, 2, 3, 4, valency will also be 1, 2, 3, 4. If valence electrons are 5, 6, 7, valency will be 3, 2, 1. What is the relationship between the group number and number of valency electrons? So this is actually valence electrons. Can we say that number of the group number is equivalent to number of valence electrons? Because if group number is 1, your valence electron is 1. If your group number is 2, valence electron is 2. Group 3, valence electron 3. Group 4, valence electron 4. Group 5, valence electrons 5. Group 6, valence electron 6. Group 7, valence electron 7. So relationship between group number and number of valence electrons is number of valence electron is equal to the group number. Okay, let's go to the next question. Explain the relationship between number of valence electron and valency from elements sodium to aluminium. So we can write for elements sodium to aluminium, for element sodium to aluminium, valency is same as number of valence electrons, because valence electron 1, so valency is also none. Because why? Because number of electrons are lost from sodium to aluminium to complete, or we can write to attain, the electronic configuration to attain the electronic configuration of nearest noble gas. So basically over here what we need to understand is why the valency of sodium is 1, because it will lose 1 electron so that it becomes 2,8, which is the electronic configuration of neon. Now elements from phosphorus to chlorine. Can anybody tell me? Now it's a 2-mark question again, phosphorus to chlorine. So what is the trend you are observing? Number of valence electrons and valency. Yes. Anybody? Phosphorus to chlorine, what is the relationship of valence electrons and valency? Are they same? Yes, are they same? Can I say it is 8 minus the number of valence electrons? Phosphorus to chlorine, valency is 8 minus 5, over here 8 minus 6, and over here it is 8 minus 7. Can I say that? Yes,
Yes.
or no? So please tell
Yes.
that. So valency of phosphorus to chlorine is 8 minus the number of valence electrons. 8 minus number of valence electrons. Because this is the number of electrons which is needed, which is gained by atom to complete its outer energy shell. Okay, to complete its outer energy shell. Okay. Across the period, the elements change from metallic to non-metallic. Describe how the type of oxide changes across the period. Yes, we did it just now. Remember, I had told you across a period how it is changed. If on the left hand side they are metallic oxides, what are metallic oxides? What type of metallic oxides are? Are they basic or acidic? Yes, metallic oxides. So it is going to be metallic to non-metallic. So it is going to be basic oxides to amphoteric oxides to acidic oxides. Okay. This is about bonding. So, but still we can do this question. Now describe how the type of bonding in chlorides formed by these elements changes across the period. Now we know that left side LHS of periodic table. What is LHS of periodic table? Metals or non-metals?
Metals.
Yes, LHS is metals and right hand side is non-metals. And what is chlorine? Chlorine is a non-metal.
A non-metal.
Yes. So if I have a metal with chlorine, okay, metal with chlorine, which is a non-metal, the bonding will be ionic. So this we are going to study in our next topic. And we have a non-metal plus chlorine, which is also a non-metal, then the bonding will be covalent. Yes. So it will be ionic bonding. It's a 2-mark question. So ionic bonding for chlorides on the left and covalent chlorides on the right. Okay. And moving on to the last question. Scandium is a low density metal which has only one oxidation state in its compound. Scandium compounds are white solids which form colorless solution. Titanium, which is the next element in the period, as is far more typical transition element. How would the properties of titanium would differ from those of scandium? So in short, they are actually asking you about the properties of titanium. So titanium means you're talking about properties of transition metals. So if scandium has a low density, what is the density of transition metals? It's a 3-mark question, so expecting 3 properties. So can we say that titanium will have high density? Yes, can we say that? Because transition metals have high density. Second, if scandium are white solids, so can we say titanium forms colored compounds? That's the property of transition metals. Then we can also say that titanium has variable oxidation state. Titanium has variable oxidation state. And one more point, they can act as a catalyst. Any 4 points depending on the marks. And this is the overall closure for the periodic table. Okay. And next topic, we will be studying about the bonding. So that will be our last topic. So today by night or tomorrow, I'm just going to give you the thing that next week there will be a last topic, and the next preceding week, which is from 22 to 25, that week will be a test week, because we will be finishing whatever the 5 chapters which was decided. So before ending the whole program, I want to take a test, so that it should be like you should learn also these topics. So depending on whatever 5 topics we have learned, so there will be a test. So I'm very much telling you in advance so that you can start preparing for the test, and it will be in the week of 22nd August. So yes, all together, all the 5 topics which we have learned till now. So periodic table, particulate nature of matter, separating techniques, bonding, and I think one more, atomic structure, all together. No, it's not one topic per day. It is not one topic per day. It is all the topics together. Okay. Still, I will just confirm with you guys, because like when is the date, 22nd of August, or when it is. So I will definitely let you know. So I will put that in the group. So by tonight or tomorrow. So we are meeting next week, Sunday, same time at 11 a.m. And we will be starting with the topic bonding. So till then, bye-bye, take care, and have a nice week. Bye-bye.